Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
On an SFL approach to sentiment, has done various pieces of work in sentiment and text classification, and currently finishing, right?
finishing
finishing his PhD on systemic feature extraction for text categorization, so in the same area. Okay.
Thank you very much. So the work that I'm going to show you today, as Michael's just said, I spent the last 4 weeks at the Illinois Institute of Technology working with Shlomo Argamon. And so this, just to keep it kind of fresh and interesting, I'm only going to talk to you about things that I've just been doing now. So it's only been a 4-week project. As you can imagine, there's only so much that gets done in 4 weeks. But I think I've got something quite interesting to show you. And this is a reasonably different approach to a topic that's seen a lot of attention recently, which is sentiment classification. Coming at it from somewhere slightly different, but do keep in mind when I'm showing you these things that I've only been on this specific track for 4 weeks now, so it's all been pretty new. And thank you very much for having me here today. It's a pleasure. Okay, so I'm going to start by making a bold claim, just to wake you up, I guess, because it's still early. Computational linguistics is still linguistics, and this is something that I think, especially these days, people may lose sight of, because a lot of the computational linguistics world is very highly computational. Every time you're solving a problem that deals with language, whether you like it or not, you're dealing with a linguistic theory. So if to solve your problem, you're counting words in text, then you're saying that the only useful feature of language that you need is that there are words in text, and some of them occur more frequently than others. And that's not just a statistical model that helps you solve a problem. That's actually a reflection on how you're thinking about language when you're trying to solve that problem. And so every time you do something computationally, you're making some assumptions about how language works. And that's something that I find is really valuable to keep in my mind when I'm doing this stuff, and maybe you can when you're watching this presentation as well. Okay, so I'm going to talk a little bit about sentiment. I believe you had another talk about sentiment reasonably recently, so you should know what I'm talking about. Then I'm going to give you a background on systemic functional linguistics, which is the particular linguistic theory that I'm going to be using in my research. And it's different enough that it needs a little bit of explanation, and so I'll talk about that. Also, how it's been used for computation so far, both generation and analysis, which is the work that I've been doing. And then appraisal theory, which is the piece of SFL which deals explicitly with the phenomena we're interested in, which is opinion and sentiment, things like that. I'll show you a particular proposal about how we can work with appraisal, how we can analyze appraisal in text, and then I'll apply that to I'll show you some initial results from using that to classify movie reviews, which is one of the kind of classic tasks for sentiment classification. In case you're counting, I think I've got about 45 to 50 slides, so you'll know how I'm going. You can please tell me to either speak slower or speed up, depending on what's going on. Okay, so there's this new, reasonably new piece of text categorization, and there's a whole lot of words that are being used about it. Things like subjectivity, opinion, sentiment, and in some cases these are being used interchangeably, and there's a bit of a blur around exactly what's going on in this field. So usually when people talk about subjectivity, they mean, does this text contain opinion, as opposed to just being a text about facts. So this is the kind of classical breakdown between journalistic reporting and an editorial piece in a newspaper. Sentiment, although it's used to describe the entire field, when people talk about sentiment classification, they're talking about sentiment being an expression of either a positive or negative opinion about something. So the classic example is in a review. And opinion is the more general kind of information extraction approach to saying, what opinions are being expressed by who about what. So there's more types of opinion being in play there, and this is related to bias, which is another area that I'm interested in. So all of these, whether you're talking about subjectivity or whether you're talking about opinion or whether you're talking about sentiment, all of these fall under the heading of appraisal within SFL. So if it's handy for me to have a general term that describes all of these different parts of this field. So that's appraisal. So the challenge here is to try and identify sentiment in text. And here's a couple of short examples, both taken from movie reviews from the corpus that I'll be showing you more about later. Both from science fiction films. The first one from Star Trek. They were not at all interesting or inventive. This is talking about the special effects in Star Trek Insurrection. So, and the second one is Hollow Man, and this is one of the favourite sentences that I've found over the last 4 weeks of working with this corpus. That such a fantastic premise is so thoroughly wasted is the surest sign of the sheer creative bankruptcy of the movie. So someone really didn't like Hollow Man. So if we want to try and identify the sentiment in here, how about bag of words? We've got interesting, we've got inventive. You might have not in your list of bag of words, but you also might remove it because lots of people have stop word lists that keep things like not and but out of their lists. And if you're clever, you might have at all as well, so it's a multi-word expression. And on the other side, we've got fantastic and thoroughly sheer creative, bankruptcy, movie, and wasted. So the relationship between these two sentences and these two bags of words is pretty obscured just by looking at the list of words that are involved. It's obvious that there are relationships going on here within the sentences that aren't being captured. So perhaps we need a better model than bag of words if we want to look intelligently at what's going on with sentiment. So what would we like from another model? We're going to need some kind of constituency because we've seen that there's a small amount of glomming here of nots and varies and things like this. But it's not really about parsing. This is not a big syntactic problem that we're working on. We'd like a way of talking about meaning in the text, but this isn't necessarily just meanings about the facts in the world. It's not about how many stocks were bought or sold or how many people were killed, things like this. It's not necessarily factual representations, but we want to try and get at the meanings of the opinions being expressed. And if we want to pick a linguistic theory, we need one that we can approach computationally and actually get somewhere with. So, there's a lot of people with a lot of linguistic theories that might have very good characterizations for sentiment, but we need something that we can actually implement and do something with. Which leads exactly to my favorite linguistic theory, which is systemic functional linguistics. So I'll call it SFL for the rest of the time unless I need to spell it out. So it's linguistics, which here really means it's a theory about communication in language. So everything that you'll see with SFL embeds language as a method for communicating meaning between people in social situations, which is a broader definition of language than you'll get in a lot of linguistic theories. It's functional in that the distinctions that are made in the language are based on language use in practice. So the SFL is an adherent to corpus linguistics. It's all based on actual usage of language in practice. And it's systemic in that language is described in terms of choices within semantically organized system networks. And so you can see here it's a linguistic theory. I haven't mentioned syntax or grammar or formalisms like that at all. It's about communication, it's about meaning. And if I had another word in red on here, it would be social as well. But okay, so let's talk about system networks. Has anyone here heard of or used SFL, to have any familiarity with SFL before? Yep, so SFL has a larger following in Europe and Australia and New Zealand, for instance. Yeah, this is Halliday's work. Yeah, so this is historically come out of Firth, and then Halliday. We'll see. I don't have Christian Matheson's name up here. Bill Mann at ISI has worked with this as well. So this has come out of Halliday's theories of kind of 1950s onwards.
For discussion here, words like meaning are actually very misleading. It's easier to talk about it than that here in terms of distribution. That gets a bit vague.
Sure.
Right? But distribution is something we look at and talk about. And the difference is that Halliday and Firth would take distribution very seriously. American structuralists and outside.
Yeah, that's right.
And so when you use the word meaning, here it's interpreted to mean not all the Halliday and Firth.
Okay. So I should probably clarify that. Another interesting part of Halliday's approach from the very beginning is that SFL is probabilistic. Most of the way that you're producing meaning is not by discrete choices, but by skewings in particular directions within these system networks. So hang on, I should explain what system networks are before I say this. System networks form the basis of the description of grammars within SFL. They're semantically organized networks of choices between possible distributions. They will end up having realizations in particular grammatical constructions or in particular words, but that decision is only made at the most delicate level within these system networks. Up until then, you're making choices between possible distributions or meanings. And by selecting across all of the systems in your grammar at once, you'll end up determining the final text. So I'll just show you an example of a system. I hope you can see this. Don't get scared, it's big, but it's not that bad. So we're looking at conjunction here. If we have two clauses and we'd like to join them together in some way, then the way that we join these two clauses together expresses a meaning relationship between those two clauses. And so in SFL, this is broken down in terms of the conjunction system. So we could choose to use the second clause to elaborate upon the first clause. So we would be performing elaboration here. If we'd like to use it to clarify the second clause to clarify the first clause, then we can choose a realization such as rather or specifically. So, and as another example, if we want to say something more about the first clause using the second one and about when it happened, we could say something like next or afterwards. So you can see that the choices that you're making all the way down, you're saying, well, I'm going to choose to enhance and I'm going to choose to add some meaning about the spatiotemporal relationship. All of these are choices between the type of meaning that you'd like to make, rather than choices between words or choices between structures. At the base level, it's going to end up influencing the grammar, influencing the words that you choose, but that's not the way that you're making your decisions. So this is the way that system networks work. Just one other general point about SFL is that they work on the basis that there's three strands of meaning which are known as metafunctions that are all present in all text all of the time. And these are, so first there's the ideational metafunction, and this is meaning about the external world. This is experiential knowledge of the world that's being expressed in the text. This is usually what you're getting at with things like topic-based text classification and usual information extraction. There's the interpersonal metafunction, which is the relationship that's set up between the speaker and the listener. So for instance, right now, the information that I'm conveying as a speaker here is as a scientific person conveying, giving a presentation in a reasonably formal academic context. And that's separate from us talking in the pub, at the end of the day. And the third type of meaning is textual meaning, which is how the text forms a cohesive whole. So this is related to rhetorical structure and cohesion, and a lot of genre and style work can be analysed in terms of how you're putting your information together in your text. So when we're working with SFL, the things that I think that are good reasons and the good points about working with SFL is that it's an existing well-developed theory. So I get to leverage the fact that clever people like Halliday and Christian Matheson have been working on this for a long time, and they've come up with a good theory that we can learn from. It's semantically oriented. So if the distinctions that you'd like to make in the text you're working with are semantically based, they're based on categories of the meanings being made, then SFL sounds like a good thing to be using. And it's a general description of language, as most linguistic theories are, which means that rather than developing a specific theory for one problem, whether that be a computational theory or otherwise, then hopefully tools that built, tools that use general theory should be portable between domains. So when we analyze language in general, we should be able to move that to other domains. Now, the bad things about working with SFL, and this has been part of what's constrained its use in the past, there's very few computational tools or computational resources that have been built so far for working with SFL. It's an open-ended theory. While there's a core that everybody agrees upon within the SFL community to do with how language works, there are a lot of open issues there, and there are a lot of things that are under sometimes quite strenuous debate about how SFL should represent language. And because most of the analysis so far has been manual, a lot of it is reasonably informal and context dependent. When I was writing this slide and I was putting up the bad points about SFL, it struck me that at least the second two here are actually kind of problems with natural language in general. You know, so maybe SFL's got these problems because it's actually trying to describe language which is open-ended and people don't agree on how it works, and it is informal and context dependent within the community. So take that how you will. Okay, so talking just very briefly about what's been done with computational SFL, there's been a long history of SFL being used for text generation. It actually started back with Sherdlu, which you hopefully have heard of from AI, historical AI stuff like Block's World is Sherdlu. And it's very famous. It's very famous, you know, as an AI thing for, you know, pick up the red block, put it on top of the green one. But all of the text generation that was done in there was done from a functional perspective. The biggest projects in text generation have been the Penman system, which uses a grammar they developed called the Nigel grammar at USC ISI, with Bill Mann, Christian Matheson, people like that. Its successor is a multilingual text generation and linguistic workbench called KPML, which is based at the University of Bremen. But this has all been on the text generation side, so it's been very successful there. And it's obvious when you look at, I mean, if you've got some if you have some goals for text generation, it's very easy to apply the systemic process to that. Doing the reverse has been looked at less. One of the first ones was Mick O'Donnell, who did some work on classifying clauses based on their systemic types. That's more internal, just looking at SFL, using computational linguistics to analyze SFL in SFL terms. More recently, myself and independently, Shlomo Argamon have been looking at using systemic features for text classification. So that's what I'll explain that a little bit more now. If we have some set of systems that we're interested in, and we can then, and we know how they're realized as sets of words, for instance, then we can find the occurrences of these systems and how they're used within any particular document. Based on how often each different part of the system is used, we can build comparative features. So for instance, if we were looking at the expansion system that I gave as an example a little earlier on, we could build a feature such as the percentage of expansion that's elaboration, so one particular type. And this is a feature that relates to a choice that's been made in terms of how you're making your meaning. So it's not a choice between words here, it's a choice higher up in the system. We can make these features at every level, including the lexical level. So we can say what percentage of elaboration, of addition, of additive elaboration was done using the word and, you know, for instance. So we can have these at every level of delicacy, and we get nice smoothing properties out of that. Now, we can only make these features because we've got a model which explicitly lets us talk about distinctions in meaning. If you've only got bag of words, you could say how often does this word occur versus how often does that word occur, but whether there's any useful meaning, that is debatable. In terms of applications, we've looked at classifying documents in terms of their interpersonal distance. There's been work on looking at the differences, for instance, between historical and experimental sciences based on writing style, and financial scam detection on the internet. And some of the things that have been common themes throughout the applications has been that having features at all levels of delicacy has been very useful, and the features that end up being, and the features that you get have a lot of explanatory power. So instead of a feature just saying, it being a number in a graph that says if we use this feature we can get better results. It's been reasonably easy to come to linguistic conclusions about why these features have been useful. Okay, so let's move on now and talk about appraisal theory, which is SFL's description of how opinion is realized in text. I'll start with a quote from Peter White's website about appraisal theory, which describes it quite well. Appraisal theory is an approach to exploring, describing, and explaining the way language is used to evaluate, to adopt stances, to construct textual personas, and to manage interpersonal positionings and relationships. So this is much bigger in scope than just sentiment. This isn't a theory about how to say things are good and bad. It's a theory about a much larger thing, which is about evaluation and interpersonal positionings in general. The two main linguists who are producing resources for appraisal theory are Jim Martin, who I'm lucky enough to have at the same university as me, and Peter White, who's at the University of Birmingham. The resource that we've been working with most is a textbook that hasn't actually been published yet, but it's about to be published on appraisal theory. But there's been published work before this on different pieces of appraisal theory. Here's a big picture look at what systems are involved in realizing appraisal in text. Starting at the top, so this means that we're going to have all of these all of the time. They're all realized simultaneously. Starting at the top, we have attitude, which is the type of sentiment, the type of opinion that we're expressing. I'll talk about that more in the next slide. Next, we have graduation, so that's what the intensity and the prototypicality is of the appraisal that's being expressed. Orientation, obviously this is one that's important to us for sentiment analysis, whether the appraisal is positive or negative. Modality deals with the likelihood or the probability, so this is a confidence thing. So we're not working with modality directly at the moment, but it's to do with the confidence levels of your appraisal. And polarity is whether you've negated the terms that you're using. So this is the high level of what's involved in appraisal. Here's another one of these big scary system networks, this time for attitude. I'll just go through this very quickly. Attitude is the distinction between the types of appraisal that you can be making. The first distinction is between affect, which I have here in the center, and appreciation and judgment. Affect is when you're expressing your personal emotional state in relation to appraisal. So words such as happy and gloomy and things like that. Both of appreciation and judgment are evaluations about external entities. Appreciation talks about objects, or it's when you're regarding things as objects. Judgment talks about things when they are sentient, agents in the world, or you're treating them as if they are. Appreciation here, for instance, breaks down even further into a variety of categories. I won't go into this in much detail, but one that we'll look at again later is reaction impact. So this is the impact that an object will have. So upon your viewing of it, then it will have these. It will have this response in you. So amazing and compelling and dull and monotonous, for instance. So one thing that you can see here is that, well, there's a couple of things. First is that there's a few levels of delicacy here. There are more levels of delicacy with affect as well, but I haven't shown them. Things such as happiness and security and so on. Second is that there's no distinction being made at the moment between positive and negative, because this is just dealing with attitude type, not orientation. So this is being intersected from across here with another dimension, which is the orientation that we choose, which will then divide these. And I've put the good ones on one side and the bad ones on the other side. So this is how attitude type works. But what is it that we can actually say? Why should we bother with attitude at all? Why shouldn't we just look at, is it giving us anything useful? I think it is. So here's a couple of different movie reviews of Crouching Tiger. I just adore that new movie, Crouching Tiger. It really thrilled me. And here's another one. the new year has provided a masterpiece in the shape of Ang Lee's martial arts epic. Now, both of these are positive, right? They're both saying good things about this film. But the one at the top is a personal expression about how the movie, so in this case, it's I just adore this film and it really thrilled me. And the second one is much more supposedly objective because we're treating the movie as an object, and these are statements of appreciation rather than affect, saying that it's a masterpiece and it's an epic. Now, attitude is not a property of adjectives alone, as you can see here. Here are two nouns. Well, epic functions as both, but here are two nouns that are both carrying appreciation in this case. So if we take attitude into account, then it would be possible to, hopefully would be possible to distinguish between the different types of attitude that are being used in text. And this may come into play in terms of performing text classification. Very quickly, looking at graduation, we can change the intensity of appraisal by using words such as somewhat for low intensity, or very or quite, or maximizers such as utterly or totally. Interesting here is also, as well as modification, which will give you lexical intensity upscaling and downscaling. Individual words carry intensity, of course, so the example here is like the verb like versus the verb love. This is lexicalized intensity, so love is higher, is the same attitude, but it has a higher lexicalized intensity. And with focus is about prototypicality, whether the item that you're talking about now is a prototypical member of the general class. So we can use words such as a bit and kind of to soften that, or words like true and truly to sharpen that. Polarity, very simple, just kind of no, not, and the contraction nt. And unmarked polarity is the default with no realizations. All right, so now that's a brief overview sketch of how appraisal works. Now we want to work with this computationally. The basic idea is to use appraisal expressions, which are just templates with slots to fill in a variety of attributes for each instance of appraisal that we find in text. I haven't read it because it came out while I've been over at IIT and I haven't had access to my copy of Computational Linguistics, but I've been told that in the latest volume, Janice Weber, who's done lots of work with subjectivity, from kind of 1990 onwards, has used text with basically another ontology, a way of mapping out all of the different attributes that subjective text can have. And I haven't read it, so I can't comment anymore, but I dare say it will. Many of the dimensions will be the same. And I want to stress that although the framework that we're fitting into here is a systemic framework that's describing appraisal, the way that we get at all of the various dimensions doesn't have to be systemic. So we want to use whatever available techniques we've got at getting whatever information we can to fill these slots as well as we can. So for instance, with attitude, we can build a lexicon, which is what we did here, or we can try and do it automatically. And there's been a little bit of work on using a similar process to semantic orientation, which uses either corpora or the internet and search engine as their query tool to automatically build orientation information for terms. There's been a little bit of work doing that for attitude, but it's been pretty inconclusive so far. If we want to find orientation, the classic way would be to use semantic orientation, which has shown to be pretty useful in sentiment analysis. There are some issues to do with kind of anchor terms and things like that, but it seems that there's promise in here in terms of automatically classifying words according to orientation. We know about polarity. We can just do it lexically at the moment. Force, at the moment we're going to just limit ourselves to lexicalized force, but if you want to try and find out automatically the force in a greater number of words, then you can use morphology, for instance, in some cases. So greatest is a more intense version of great, and you'll need some type of approach for looking at intensity in a larger lexicon. And we've got focus, we've got modality. Two other things which we'd like to know about every appraisal expression is who's doing the appraising and what are they doing appraisal of. Both of these, ideally, you'd be looking for subjects and objects and things like that, which would require parsing. You can, if you're willing to sacrifice part of the accuracy or the level of detail that you're working on, you can probably do this heuristically, and some of the sentiment papers have done this. For instance, instead of looking for the appraiser, you can just look for whether it's the reviewer or it's somebody else expressing their opinion. And with the appraised, what's being appraised, you can just look for whether it's the actual item under review versus something else. So they're easier steps that you can do if you want to try and fill these slots. And here's a quick example. Here we've got the acting is really quite incredible. We don't have an appraiser. There's no, if it was I think the acting is really incredible, it would be I. We have the appraised, which is acting, and the appreciation and orientation come from incredible. The focus is sharpened by saying really. The intensity is high, and that comes from both of these. These are both intensifiers, and there's no polarity in here. So ideally, we'd like to fill all of these perfectly accurately all the time for every expression of appraisal that exists in the text. Well, it didn't happen in 4 weeks. Instead, we decided that we'd focus just on adjectival appraisal. So adjectives seem to be a very rich way of expressing appraisal. They're definitely not the only one. We've already seen examples like masterpiece, and verbs such as like and love, which are really strong carriers of appraisal information. So we're just going to focus in this little pilot study on one type of expression, just adjectives and adjectival groups, so we can get things such as all of these here. The good thing is it uses most of the core elements of appraisal. The bad thing is it's only a small part of the picture. We're not even trying to look for appraised or appraiser, which is one part of adjectival, the relations that adjectival groups have. We're not looking at any nouns, we're not looking at any verbs at all. One of the problems, as I said earlier, with SFL is that we just don't have the lexical resources in place to do large studies with SFL at the moment. So we had to build some. SFL textbooks usually just have examples of how systems work, a few words here, a few words there. So we've used them as seeds to build larger lexicons. We're not doing this in a totally automated fashion because we still want to keep high precision in our system. So instead we just do it in a semi-automated way. We use resources like WordNet and online electronic thesauri. We start with seed lists. We do a lexical expansion. We aggregate and rank the terms in there, and then go through them in order of most likely to be a member of the group downwards, and then do a manual selection. So this is time-consuming, but it's not that time-consuming. So for instance, I mentioned reaction impact before, so the impact that something like a movie will be having on you. We start with terms such as captivating and fascinating and remarkable. These are given to us in an SFL textbook that describes appraisal. We get a large list of candidates that we can rank in terms of their likelihood, just heuristically, and words that occur at the beginning, such as noteworthy, impressive, enchanting, are probably good candidates to go in here, and things that are at the end, such as, in this case, things like propelling and forcible, we probably won't keep them because they're not parts of this system. And in this case, we selected 86 manually. It's a lot quicker selecting things from lists than it is building these things yourself. We managed to build some systems in about a man week with over 1,000 words spread across both positive and negative affect, appreciation and judgment, and a fair few for force as well. This is by no means complete, and this is only based on our particular intuitions about how to build this system as well. So this has just been what we've done quite quickly in order to get enough resources to see how appraisal functions in movie reviews. Now, all of the attributes that I've talked about, there's all these slots that we want to fill in an appraisal expression, and there are modifiers that modify those attributes. They don't just exist in isolation, they work together and they influence each other. So I thought I'd do a little example of this. Take the word cool, and here I'm using it in the term to mean good rather than cold. So cool. It's appreciation, where it can be judgment as well, but let's take it here as appreciation. The orientation is positive. Something being cool is a good thing. The intensity is normal, so we haven't done any work on lexicalized intensity here at all, and there's no polarity. We can say that's so cool. If it's so cool, the intensity is high. We can say it's not cool. In this case, we have marked polarity and negative orientation. So the not has flipped the orientation of cool from negative to positive, positive to negative.
How do you deal with things like I received this from cool?
Sure, so if you... Yep, so the ambiguity, that we're not dealing with ambiguity at all in this. Ideally, you'd have, one solution is to try and do word sense disambiguation for everything. The other is to say that if you let it occur perfectly ambiguously through your system networks, you're going to get smoothing and statistically across the whole lot it'll end up affecting. So if this turns up as both of them coolly, yeah, cool, yeah, a cool reception, yeah. So yeah, so if you can have the way that we've solved this, we've worked with this so far is just by allowing things in multiple positions within system networks. So you'll get multiple counts of these coming up through it. The idea is that rather than having to choose, we can allow both of them, and then it will sort itself out. Okay, so now we can say that it's not so cool. So this is not very good, and here. First we have so cool, so the intensity has been heightened. But when we say not so cool, the not applies to both the so and the cool, so that the orientation is now negative and the intensity has been swapped from high to low. So if you think of an example like it's not very good, that doesn't mean that it's very bad, just means it's a little bit bad. A question also is, why do we keep polarity as a separate feature rather than just building into orientation? Because orientation is where polarity ends up being. If we keep polarity as a separate feature, we can keep the difference between happy and not sad, for instance. They're both expressing positive affect, but they're doing it in a different way. So that's why we keep polarity as a separate feature. Now, if we can say so not cool, yes?
What do you do about things like he was not unhappy with the house? Not very appreciative
perhaps. Yep, so something like not unhappy will start as negative oriented affect, so because it's a personal emotional thing. If we have lexical intensity information, unhappy, we can even just treat it as normal negative affect. Not unhappy, we'll flip it to being positive, because if you're saying that you're not unhappy, then it will be positive, but preferably it won't be very positive, because we've got a double negation going on. We haven't dealt explicitly with double negation. It's still not clear to me that not very good. So there are cases in which you can say not very good. There's a marked case in which you can say not very good, which means that it's still slightly good. So you can say it's not very good, and that means that it's still a bit good. So we're trying to capture the most common unmarked case of this. You can definitely say it's not very good, and it still means that it's a little bit good, because you're of the way that you say it. So with so not cool is negative high intensity. So that's the general approach. Now, movie reviews. Movies are an interesting corpus, perhaps not ideal. They contain, some of the challenges with movie reviews is that they contain a lot of different types of text. They contain plot summaries. They contain the personal story of the reviewer going to the movie cinema and getting popcorn, which they loved, because they always loved going to the movie cinema. But their girlfriend didn't come with them, and so they were very sad. And then there are all these, as well as, if you just even look at the review, there are all these different ways that, apart from just saying, I love this film, that they can talk about it. So, there's things such as comparison where you can say, while it's not as good as, this movie, which is the most brilliant movie of all time, it's still excellent, right? So there's sarcasm things, there's a lot of of difficulty in movie reviews. And so what we're looking at here is just, can adjectival groups be any good at all at doing classifying movie reviews? We're using the same movie corpus as a lot of other people are using, which is the Cornell movie corpus produced by Pang and Lee. 1,400 movies, 1 million words. Now, because of the way that we've built our resource, we're only looking at adjectival groups. We're only covering 31% of the usage of adjectives in the corpus. This means we're only covering 9% of the words in the corpus, which is really low. So, as I've said, we've excluded nouns, we've excluded verbs. 9% isn't really very much, and we're worried at first about how this would be, but because of time constraints and things, that's what we got. So we're basing this classification on the entire document as just a set of appraisal expressions that exist in the document, and then building features from them. We're using information gain for feature selection. We're using a support vector machine for our machine learning. We're just using the Weka environment and SMO, which is a particular SVM kernel, SVM implementation, and we're using a linear kernel. So this is less focused on the specifics of the machine learning and more looking at the differences that different attribute sets will give us. We've chose this just because it's a good enough current machine learner that will let us see the differences between feature sets. So here's all the results, and I can start you at the bottom and say that this is not us. 86% is not us, and we haven't even gotten close. But if we start by looking just at the set of adjectives that we've got, so as a baseline, we'll take the set of adjectives that we've identified with no information about them. We'll just take that set of adjectives from the text and build normal bag of words features. We can get about 75%. This is movie classification into positive and negative. If we add orientation information, so as well as all of the features to do with what words exist, we now know which words we have manually classified as being orientation positive and orientation equals negative. So we can do proportional features now. We get a slight boost, so we're up to 75%. If we add attitude in there, so the attitude system that I showed before, now we know what type of appraisal is being expressed. We get a nice boost here. We get up to 78%. The numbers here have gone down because of feature selection. Less of the features were kept through here. So by the addition of attitude, now we've got these generalizations between classes of adjectives. So what this is saying is that it's less which individual words are being used, but more which classes of adjectives are being used. Now, if we work with appraisal expressions, this means that we can analyze polarity. One really interesting thing is, it was at ACL this year, and I really wish I could remember which talk it was in, but they mentioned that they'd tried using polarity, including polarity in their system, and results went very slightly down. And that really surprised me, because you would think that knowing whether something was had been negated or not and affecting the orientation proportionally would be a good thing, but in their results it hadn't been. And here we get only a very small boost, but we get a positive result from including polarity information. When we add all of the extra dimensions such as force and focus and so on, results actually go back down. So for this task, those and the force and focus and intensity are don't seem to be relevant to expressing the sentiment. And the two results at the bottom are previously published. One of just using unigrams and bigrams with a whole lot of features gets you 82.7, and then using subjectivity summarization, you can get 86.4%. So we're not near either of these results. So it's tenfold cross-validation with 700 documents in each class for a total of 1,400. So yeah, tenfold cross-validation on the training set, and then results averaged across the folds. It's actually quite a small corpus. So one of the things we want to do is work with a larger corpus. Has 2,000.
So there's a newest version.
Oh, okay.
So it's,
It's a little bigger. I didn't know about that. They also have an unannotated collection of 25,000 or so, I believe, that you can use for your own. You can work off them as unannotated review data. So having a look at a few of the useful features, these are just selected from the top of an information gain ranking. We can see that one of the best ones is the amount of appreciation that was negative. So that makes sense. But what you can see here is that it's not just saying the amount of all words that were negative is the most important. It's appreciation in particular as opposed to judgment or affect. Reaction impact, which is one particular type of appreciation, again, so that's even more specific as a class. We've got one from judgment showing up here, capacity, and interestingly, there's one group here which is, RB here is adverbs only, so we're working with where the base is an adverbial form of an adjective. So these, it makes sense. What we can learn from looking at these, for instance, is that appreciation is the part, or it seems to be the part of appraisal that's being used the most heavily and is the most correlated with sentiment. And that's something that we wouldn't have been able to know if we were just using words. Yeah, they're ratios. So these are proportions if you think of them in terms of a hierarchy here. It's automatic based on we know what the systems are that we have, and there's a multi-dimensional step where you have this system and this system and this system, and then you let them combine. So in this case,
so it's always one level over.
there's two. There's this level versus the level above, so choice within this system, or becoming more specific across another dimension. So for instance, this one here is not a versus the level above, it's specifying the negative proportion of this system versus the entire usage of this system. So we've got multi-dimensional features taken from across all of the system. But one thing that we saw was that adding force and intensity and so on, so we're making features such as appreciation where the intensity is high versus appreciation as a total, we're not giving us improvements in this task at the moment. A couple of thousand, so yeah, about 2,500 for the full set, and it will be about 1,800 for orientation, polarity, and attitude, including if you include all of the Lexis as individual proportions. If you can exclude them from it as well. So for 9% coverage and 300 features, these results are promising. They're by no means state of the art. We've learnt that attitude type is useful, knowing that appreciation is where more of the important sentiment is being carried. And here's a result that says that analysing polarity, so explicitly analysing these adjectival groups to get polarity information, not an nt and no, actually gives you better results. And that's kind of reassuring from a linguistic perspective, because if someone's saying it's not good, then hopefully we want that to mean something different to them saying it's good. So it's nice to have that confirmation, and there hasn't been anybody who's shown an increase through polarity use so far. Other dimensions didn't work so well, and we're not going so well overall. Just a couple more slides, I swear. If you follow the techniques that Pang and Lee have used in their most recent work, they're using subjectivity summarization. So this is working with prosody, the overall structure of the text, to identify the pieces that are, in their case, the most subjective, and just taking your sentiment from them. And there's also been approaches using weighting functions. Here's a graph of a review of the movie Rushmore. Now, there's not actually a line. Sentiment doesn't actually flow like this so smoothly. These should just be points, but it's easy to visualize them as lines here. So the part of me doesn't like the fact that these are lines. And you can see how here there's a big patch of positive sentiment, kind of goes up and down in the middle, and there's a big patch of positive sentiment again here. And it actually ends on a down note, because he said that the ending is rather conventional. And you can see that, so the red and the blue lines are for appreciation and judgment. One thing that we've noticed in general is that affect, at least as we're capturing affect, doesn't show up that much. So hopefully some type of prosody analysis could reduce this potentially to, say, a couple of clusters of good, some noise through here of bad. See, there's quite a few negative judgment through here, but if we know that appreciation is more important than judgment, then in the end it'll be taking the appreciation. So they've had good results doing things like that. It'd be interesting to see if we could do the same thing. We'd like to increase coverage using easy existing methods such as bag of words or nouns and so on, and using larger data sets. The data set I have in mind next is there's an opinions data set. The most interesting thing about their product reviews rather than movie reviews, each product review is classified in multiple dimensions such as ease of use, reliability, would you recommend this to a friend, I think things like that. And so hopefully we'll be able to see a difference in the types of attitude that are important for each of the different dimensions there. And the future work, this basically says all of those slots that we had, fill them all better. Extract more appraisal from text, extract it more accurately. So I guess I hope what I've said today is that SFL is a linguistic theory that we can model computationally, and we can use it to improve the analysis of adjectives through things such as polarity for appraisal and sentiment. Thank you very much. I should just briefly thank John Patrick is my supervisor in Australia. I've been working with Shlomo Argamon for the last month. My research is funded through the Capital Markets CRC in Australia, and thank you very much for having me here. Yeah.
So, I think that sentiment analysis is fundamentally interesting in different problems from many other text classification problems, and I agree a bit with your emphasis on the adjective. And it's interesting that adjectives, in fact, almost all predicates, verbs, adjectives, adverbs like not, and so on, are almost always wiped out by standard classifiers in standard problems.
Yes.
So standard problems like retrieval, off-right identification. Okay. Now, I disagree, though, in that it's a question about linguistic theory. Right? That is, I don't think the SFL stuff is really that different from just saying we're going to use a standard classifier, we're going to use some features, and then we'll overlay on top of those features some clusters.
Mm-hmm.
Those clusters happen to be given by this magic oracle or that oracle.
Yep.
It really doesn't matter.
So
Now, what I think is important is that the question is, why is it that standard bag-of-word models tend to throw out predicates? And it's my belief, going way back to a problem I worked on years ago, that the fundamental problem with predicates is to bring up the old ones all the time.
mm-hmm.
So way back when I was working on a classification problem with a three-way sentence, it was good, bad, and neutral.
Mm-hmm.
In fact, I think neutral is an important case to include in this, that this data set forces you to sort of think about
Yeah.
good and bad, but you really would like to have a control set, say something like news articles without the editorials,
Yeah.
where you really do have a kind of neutral vocabulary, and try to show how good and bad is neutral. Now, in this set, I looked at a lot of words showed up in good, not the other characters. A lot of words showed up in bad, not the other characters. Just for fun, I looked at words that showed up in good and bad and never neutral. And there were quite a few. They tended to be these predicates. They were actually words like Mickey Mouse, Mickey Dick. And you wonder, how could these words ever show up in good? Right? And the answer was that they were labeled as good if they were predicated of our competition.
Yes.
And they were labeled as bad if they were predicated of us. Okay? And these were loaded words. And, words like not would sort of be in that case, where you really can't tell me whether it's good or bad unless you tell me what it's predicated of. Right? And the whole problem with predicates is that they don't have any meaning of themselves, really, until you know what they're predicated of.
That's correct.
Now, where I'm getting at is that you're fundamentally using basically a perceptron that really can't address these basic fundamental predicate relationships. And then you focus on predicates, and you're barely able to tweak out maybe yes, maybe no, that something, a word like not, has any meaning at all. And the reason is because it doesn't work unless you can somehow get the predicate right.
I agree. So if we had the object, or the appraised, what's under appraisal, then there's a lot more information that we can extract from here. So there's a couple of points that you brought up that are interesting. The first is that you can do the same thing if you had some oracle that clustered these words for you. The oracle is language use, and SFL is one way of, it's been manually produced, but if it's been built to try and reflect the way that language is used to express these meanings. So if you can computationally extract clusters that work the same way, then that's fantastic. And there's been a guy who's just done his honours thesis at the University of Sydney, did some work on automatically classifying qualifiers and epithets, so different forms of adjectives, and he did that with no knowledge of the systemic functional groups, and the usage patterns that he obtained agreed with this theory. So if you can get groups of words that are functioning similarly, and then place them in a hierarchy, then that's fantastic, and you can do all of exactly the same approach that I've used here, but entirely automatically. I don't have the techniques to do that, so I've used somebody else's existing idea of how to do that instead. But it's functional, which means it's based on how they get used. In terms, you've mentioned that adjectives are the place that carries all the sentiment, and I actually disagree that. And there's a hell of a lot of appraisal that are being carried in nominal groups and in processes, and a lot of the relational information in there also is captured in noun and verb groups. So I think we're missing a lot of the appraisal information, and it's frustrating because there are really obvious things such as like and love and thrill, things like that are very laden with sentiment that we're not looking at all at the moment.
Well, one way to address that problem, I think, would actually be to just combine what you have, which sort of looks at it at a narrow lens, but I think still gets really remarkable accuracy by just looking at adjectives, just looking at
some adjectives, yeah.
Right. I mean, if you combine that with another classifier that does bag of words on whatever, using how the speech tag and now works out,
so
and try and see how they play together.
Yeah.
That would be really interesting.
That's next, because I think that we're showing that I take these results to say that there's some value in doing this, but if we can supplement it with a high coverage approach such as bag of words, then I think that the performance should go up again.
You normalize without thinking.
No, so the way that normalization occurs here is within system usage. So because they're proportional features, they're normalized against the amount that system gets used. So if you have a very short document that has a whole lot of appraisal information in it, it will look exactly the same as a long document with that appraisal information spread out across the lot if it was the same one. And yeah, so I haven't looked at it here, but I've got a paper which is presenting next week in Australia, which is about taking all of the different ways that you could build systemic features and then seeing which ones work best. And this system contribution, which is what this is about, tends to be better in general than system percentage, which is the document normalized version. So there are a lot of different ways that you can normalize across system, across the document, across these to get different representations of these. So I can forward you a copy of that.
I was constantly thinking about the theory of mixing colors analysis with yourself. That is, under that theory, you can analyze the pixel
Yep.
color, and then they have the notion of intensity and darkness, and then mixing together, you can predict, that this color belongs to this category, you can say. Now, under this theory, then, you kind of go out to, analogous to that theory.
Yeah, yeah.
And you can predict, okay, the low negative polarity and low intensity and plus, positive attitude, and then the mixture of these, attributes becomes something the theory can predict them.
Yes.
Okay.
Yeah. So there is the way that we're analysing, the way that they modify each other is based again on the way that SFL suggests that should be done. Thank you very much.